All right, pre-algebra students, we are moving into our next lesson about representing non-proportional relationships. For our learning target, we should be able to interpret non-proportional relationships in tables, graphs, and equations. In this particular lesson, we will first talk about what a non-proportional relationship even is, and then investigate non-proportional relationships in tables, graphs, and equations. Make sure that you're following along with your guided notes, and let's get started. First, I want to briefly talk about what a proportional relationship is. This is a little bit of review. So for proportional relationships, we know that a relationship between two quantities is proportional if the ratio between the two quantities is constant. So the ratio of y over x. Y over x must be the same in a table, a graph, or an equation. Two things will be true about a graph that's proportional. The graph will be a straight line, and the graph will pass through the origin. That coordinate is 0, 0. And in a table, we want to check for equivalent ratios. In other words, in a proportional table, the ratio of y over x will always be constant. In an equation of a proportional relationship, we need to remember that it's set up like this, where y equals m times x, where m represents the slope and x and y represent the two quantities we're comparing to each other. Here's how non-proportional relationships differ. A relationship between two quantities is non-proportional if the ratio between the two quantities is not constant. In other words, it's the opposite of a proportional relationship. A graph of a non-proportional relationship will not pass through the origin. It's going to pass through some other point. Instead, the graph will cross the y-axis at a point known as the y-intercept. You might also hear me refer to this as our starting value or our initial value. And there's one thing that should be true about the x value of an ordered pair or a coordinate for a y-intercept, and that's that x equals 0 because the point has to be on the y-axis. Here's kind of what I'm talking about. Let's say I've got a quick mini graph here. Here's my coordinate plane. And what I need to know, let's say here's a non-proportional graph. Notice how this blue line does not pass through the origin. It's going to pass at some point on the y-axis. If I were to plot this point, the x value is going to be 0. Notice how we're not moving left or right to plot this point. It's going to be 0 and then some number. We'll call it b for now. 0 number. So let's take a look at non-proportional relationships in tables and graphs and how they differ from proportional relationships. So let's take the same scenario we were looking at a few lessons back. And let's talk about Hillary. In her search for a gym, Hillary found a location that charges $10 as a one-time sign-up fee and $20 each month. And we're going to complete a table and a graph using this information. So right off the bat, I'm underlining the values in this situation. I notice that she's paying a one-time sign-up fee, which is pretty common for gyms, and she's paying a rate of $20 each month. So $20 times the number of months she's going to this gym. Let's fill in the table with this information. So again, I know that cost, the total cost, is going to equal the $20 per month membership cost times the number of months plus the $10 sign-up fee. So let's take a look. Let's say if she attends the gym for 0 months. Well, it would be $20 times the number of months, which is 0, plus the $10 fee. So all in all, 20 times 0 is 0, plus 10 is 10. Same thing with the rest of the months. For attending the gym for 1 month, this would be $20 times 1 month plus the $10 fee. 20 times 1 is 20. 20 plus 10 is 30. 2 months, 20 times 2 is 40 plus 10 is 50. You'll notice that our cost is going to jump up $20 each month. That's what that rate means. And I'm just going to fill in the rest of the table with this information. Again, multiplying the number of months by the membership cost plus $10. For 4 months, 20 times 4 plus 10, that would be $90. And then we get to the end. For X months, we're going to follow this same pattern. 20 times X plus 10. Well, we don't really know what this costs, so we're just going to give the cost a generic variable Y. So what is the slope or rate of change shown in the table? Well, I noticed that for every month we attend, we're increasing by $20. So the rate of change or the slope is 20. The value of the y-intercept. Remember, y-intercept is our starting value, the amount of money we're paying first. And that is the $10 sign-up fee. So the y-intercept is going to be 10. Is this table proportional? Well, I don't think so, because if we look at the ratio of y over x, let's say for 1 month, this would be 30 over 1, which is 30. And then for the second month, we've got 50 over 2, which is 25. Notice how my ratios are not equivalent. I've got 30 and I've got 25. So the table is not proportional. Y over x is not constant. So let's take this information and translate it to a graph. What we did in the table here is create coordinates. So months is your x value, cost is your y value. So the first coordinate is 0, 10. The next one, 130. We have 250, 370, 490, and we could keep going from there. So I know that my x-axis represents the number of months, and my y-axis represents the cost for attending this gym, cost in dollars. So I'm going to plot each of these coordinates. My first one is 0, 10. So I already know right off the bat, my line is not going to pass through the origin. It's going to pass through the point 0, 10 on the y-axis. My next point is 130. I have 250. I have 370 and 490. And if I draw a line through them as best I can, this is what I've got. You'll notice that the pattern or the points are all constant. So the slope or rate of change shown in the graph is going to be 20 again. My rise on my graph is 20. I'm jumping from 10 to 30. My change in y is 20. My change in x, or my run, is 1. So my rise over run would be 20 over 1. The value of the y-intercept, we said that the y-intercept is where our line crosses the y-axis. And what I'm seeing is this coordinate right here, 0, 10. My y-intercept is 10 because the coordinate is 0, 10. And is this graph proportional? No, it is not, because it doesn't pass through the origin. It doesn't pass through the origin. So let's talk about equations. We saw representations of graphs and tables. So if we think about equations, we're going to look at Hillary's situation one more time. And we're going to write an equation to represent the relationship between X, the number of months at the gym, and Y, total cost of membership. So remember, we said that the cost is equal to $20 times the number of months plus the $10 fee. And so when we actually go to write this equation, we're going to fill in y and x, where cost and number of months is. So it's going to look something like this. Y is equal to 20 times x plus 10. And so the slope is in this equation. Remember, the slope is 20. The slope is in front of the x. It's in front of the x. We also see the y-intercept in this equation. It's this plus 10. The y-intercept is added at the end. Added at the end. And so we can make a conclusion about non-proportional equations. We can conclude that the slope is the coefficient of x. It's the number multiplied by x. And the y-intercept is the value that's added or subtracted at the end. So non-proportional equations are written in this particular form. We're going to be using this equation a lot. Y equals mx plus b, where m equals the slope and b is the y-intercept, where our line crosses the y-axis. So here are some examples of equations. Let's identify the slope and y-intercept in them. So let's say I've got the equation y equals negative 3x plus 2. Well, in this particular equation, m, my slope, is going to equal negative 3. It's the coefficient of x. And my y-intercept, b, is going to be 2. It's the number added at the end. Let's say I've got another equation. Let's do y equals 1/4 x minus 2. So my slope, m, even though it's a fraction, is the coefficient in front of x, and that's 1/4. And the y-intercept, b, is the number that's being subtracted. Since it's minus 2, the y-intercept is actually negative 2. And one more. Let's say I've got the equation y equals, let's say 2x. I know my slope for sure is going to be 2. But my y-intercept, I don't really see a number that's being added or subtracted right here. We can assume that we are adding 0. We're technically adding 0. Y equals 2x plus 0. So the y-intercept is 0. And what's really cool about this particular equation is that if the y-intercept is 0, the relationship is actually proportional. This graph, where the y-intercept is 0, will pass through the origin. For additional practice with concepts like this, try out problems 1 through 3. I've got one more problem for us to try, and it's a bit of a word problem. It's going to take some extension of our thinking. So in this problem, Caroline is going to the state fair with a group of friends. It costs her $12 for admission, and once she's inside the fair, she can buy tickets for 75 cents each. in order to play games, purchase food, or go on rides. So, two values that are pretty important for me to notice here are the $12 for admission and the 75 cents each for tickets. So, when we write this equation, here's what I'm thinking. I'm thinking that the total cost is going to equal 75 cents times the number of tickets plus $12 admission. And this is set up exactly like the equation form we were talking about earlier. Y equals mx plus b, where m is the slope or the rate of change, and b is the y-intercept or starting value. So we can set up our equation exactly like that. Our equation would be, y is equal to 0.75x plus 12. Our slope is the rate. So once we're inside the fair, we're buying tickets at 75 cents each. The key word here is each. If you see each, every, or per as keywords, this usually indicates the slope. The y-intercept is your starting cost or your starting value. So admission just means the starting cost for the fair. The y-intercept would be 12. So let's think about what this graph would look like. If our y-intercept is 12, that means we're going up on the y-axis quite a bit. And I'm not going to be exact here, but let's say it's right here. This is where my graph would start at my y-intercept. And my slope or my rate of change is 0.75. That means it's a positive slope, which means my graph's going to be going up. It's increasing at a certain rate. So we know the graph is going to start at the coordinate 0, 12. And the graph would be a straight line with a constant rate of change of 0.75. The rise of the line would be 0.75 and the run would be 1. So that is it for this lesson on non-proportional relationships. Make sure you try out some of the additional practice problems and check your answers with my filled in notes, and ask for support in Math Help Desk if you need it. Thanks again for watching.